Today we're looking at lesson 6.3. We are going to learn how to solve a system of linear equations using the graphing method. So this is the first of three methods we'll look at. So let's review a few things about systems. As we are looking at systems, we know that a system means I have to have two equations. They have to be in the same variables. Or I could have more than two equations, but I have to at least have two. So let's look first at this line. We have y equals x plus 1. This is in our slope-intercept form, where we can easily see the slope and we can easily see the y-intercept. So as I look at this equation, I know that my y-intercept is positive 1, which is right here, and that makes sense because my scale is counting by twos, and my slope is the coefficient of x. So since there's nothing listed, this implies a 1. So from my y-intercept, I'm going to go up 1, over 1. Up 1, over 1. Up 1, over 1. And I kind of skipped here. Let's start again. Up 1, over 1. Up 1, over 1. Up 1, over 1. And so on. And this will continue all the way up and down my line. So I could go down 1, left 1, down 1, left 1, down 1, left 1 as well. For my red line, my equation is y equals 3x minus 7. So negative 7 is my y-intercept, which is down here. So from my y-intercept, I have a slope of 3. So I'm going to do a rise of 3 and a run of 1. So I'm, excuse me, going to go up 1, 2, 3, over 1. Up 1, 2, 3, over 1. Up 1, 2, 3, over 1. And that pattern will continue until I get to the place where my lines cross each other, and that is here at this point. So if I need to label the solution, then I'm going to label this point. This point is over 4 and up 5. And that is my solution to this system of equations. For this your turn problem, make sure you get this one graphed on your notebook paper and show it to Mrs. Morrison at the end of your notes. What is the solution of the system represented by the graph? So again, let's look at my equations. I have y equals x plus 1. 1 is my y-intercept, so that's the first point that I graph, and then I'm going to use my slope to find the other points. Since there's no number in front of the x, that implies a 1. So if my slope is 1, I'm going to rise 1, run 1, rise 1, run 1, rise 1, run 1. Or I could also, from my y-intercept, I could go down 1, left 1, down 1, left 1, down 1, left 1, because a negative rise and a negative run simplifies to a positive slope, and I see that my line is sloping up from left to right. Let's look at the other line in my system. X plus y equals negative 3. This is no good because it is not in slope-intercept form. So I want to put it in slope-intercept form by solving for y. Let's get y by itself. To do that, I need to get rid of the x, which I can do by subtracting x from both sides. X minus x is 0, so I'm left with this positive y. And over here, I have a negative 3 and a negative x. So I'm going to write these in this order, minus x minus 3, because that is my slope-intercept form. So now I can see my slope is a negative 1, and my y-intercept is a negative 3. So I'm going to start at my y-intercept of negative 3, which is right here. And from here, I'm going to rise a negative 1 and run a positive 1. Or I can rise a positive 1 and run a negative 1. Either way, only one of my values can be negative. So a positive rise and a negative run. And that gets me to the point where my lines cross right here. This is my solution, the point where they cross. So this point is left 2, down 1. So that is the point. I'm going to do it in purple. -2, -1. And that is the solution to my equation, or my system of equations. So make sure that you have that one in your notes to show me. So sometimes you're going to be asked to estimate the solution of the system by graphing the equations. And the reason it says estimate is because graphing equations to find the solution can tend to be a little bit inaccurate because it requires us to graph perfectly to come up with the exact solution. So usually we'll use this method to estimate. So let's look at our system. My first equation is y equals 2x. I don't have a y-intercept listed. If I think about slope-intercept form, y equals mx plus b, I'm not adding anything to this x, which is the same as adding nothing, right? So that gives me a y-intercept of 0. Now I'm going to use my slope to count out my next points. So my slope is 2. So from my y-intercept, I can rise 2, run 1, rise 2, run 1, rise 2, run 1, or I can go down 2, left 1, down 2, left 1. All right, and then I can, graph my line. There we go. Now let's look at my second equation. Y equals -6x plus 4. I'm going to start at my y-intercept, which is positive 4. So on the y-axis, I put a point at 4, and now I'm going to use my slope, which is -6. So I'm going to go down 6 and over 1. So from here, I'm going to go down 6. Oops, I'm sorry. I started with the wrong y-intercept. That would make a difference. Well, let's start again. We're at our y-intercept of 4, and I'm going to go down 6 and over 1. Down 2, 4, 6, and over 1. I could also go up 6 and left 1. And now let's go ahead and graph our line. And look for the place where these lines cross each other, which is here at this point. So this point looks like it is over about 1/2 maybe, and up 1. So I would call this point 1/2 or 0.5, 1. So that's how I've estimated my solution. I can't say that's exact, but that should be pretty close. All right, let's do this problem on your notebook paper to make sure that you can show Mrs. Morrison. Again, we're going to estimate the solution of the system by graphing the equations. So let's start with our first equation, y equals 3x plus 1. I'm going to start with my y-intercept, which is positive 1. I graph that point on the y-axis. Now I'm going to use my slope of 3. So a slope of 3 would be rise 3, run 1. So I'm going to go up 1, 2, 3, over 1, up 3, over 1. Or I could go down 3, left 1, down 3, left 1. And let's connect our points in a line. And let's check out our second equation. Uh-oh, this time it's not in slope-intercept form. So I want to solve for y. I want to get y by itself. So first I'm going to get rid of the x. I'm always going to get rid of what's furthest away from my variable and then work my way closer. So I'm going to start by subtracting x from both sides. That leaves me with negative 3y equals negative x plus 1. Now, to get y by itself, I need to undo this times negative 3. So I'm going to divide by negative 3. So these cancel, and I'm left with y over here. But now I have negative x divided by negative 3. Negative divided by negative makes a positive. So this gives me 1/3 x. And I also have to divide a positive 1 by my negative 3. So a positive divided by a negative gives me a negative. This is also 1/3. So as I graph this line, I'm going to start at my y-intercept, which is negative 1/3. So I'm going to be estimating here, which is why my graph can't give me an exact answer. That looks like about negative 1/3 on my y-axis. And from here, I'm going to go up 1 and over 3. So I go up 1 and over 3, up 1 and over 3, or down 1 and left 3, down 1 and left 3. So I end up with this line. So the place where they cross is right about here. This is going to be harder to identify this location. It looks like it could be negative 2/3 for an x value, but it's almost all the way down to negative 1. So I might say that this is about negative 2/3 and a positive 1. So again, you can see why we're estimating here. It's hard to say exactly, but this is about negative 2/3, negative 1 for our solution. Now, sometimes you might have to write the system of equations. So let's look at a word problem here. Package A for photography is $25 for 12 photos plus $40 per print. Package B is $30 for 12 photos plus 15 cents for extra prints. So we want to take this information and write it into an equation. So for package A, we know that we can get 12 photos for $25 and then add on 40 cents for an extra print. So for this equation, I'm going to use y equals mx plus b form, but I'm going to use the letter C to stand for cost. So what I know is it's going to cost 40 cents per extra print. Plus, it's going to cost me $25 for those first 12 photos. Plan B, my cost is going to be 15 cents per photo. And on top of that, I'm going to have to pay $30 for the additional, or for the original 12 photos. So as I graph this, let's start with equation A. I'm going to, on the y-intercept, put my point at, or my y-axis, I'm going to put my point at positive 25. So if I'm counting my 20s, then 25 should be halfway in between here and here. So there's my y-intercept. Now from here, I have a slope of 40 hundredths. So I'm going to want to reduce that because that's hard for me to think about. So if my slope is 40 hundredths, I could think of it like this, which if I reduce that, that would be 4/10, which would further reduce then to 2/5. So I'm changing my decimal to a fraction, and from my y-intercept, I'm going to rise 2 and run 5.